This is section 4.3, part A, trigonometric functions on the unit circle. We're going to let theta be any angle that's in standard position, and point P is going to be located in some point xy, be a point on the terminal side of your angle theta. R is going to represent the radius or the distance from the origin to that point P. And to find the length of R, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. But if we rearrange it to find the R value, we're going to have R is equal to the square root of x squared plus y squared. Now once we have the R value and we know our x and our y, we can then look at our different trig functions. So since this is our angle, the side across from the angle tells you how far down you've gone, so that's your y value. So that's the opposite side. The side between the angle and the 90 is your adjacent side, which is also the same distance as over here, which is your x value. And the hypotenuse, or the distance across, or the side across from the 90, is your r value. So we know from our previous sections that sine is opposite over hypotenuse. But in this case, the opposite side is y, the hypotenuse is r. Cosine is adjacent over hypotenuse, or x over r, and tangent is opposite over adjacent, or y over x. Remembering the other three trig functions are just the reciprocals of the first three. So let 8, -6 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trig functions of theta. Now since our r value is a radius, it's a distance, distances cannot be negative, so the r value will always be positive. But we need to find that r value first. And we know r is equal to the square root of x squared plus y squared. So we're going to do 8 squared plus -6 squared, or 64 plus 36. So r is equal to the square root of 100, or r is equal to 10. Now we know sine of theta is y over r, or in this case, -6 over 10. Cosine of theta is x over r, or 8 over 10. And tangent is y over x, or -6 over 8. Your remaining 3 trig functions are just the reciprocals of your original 3. So this one's going to be 10 over -6. Secant of theta is r over x, or 10 over 8. And cotangent of theta is x over y, or 8 over -6. Now we do have quadrantal angles. These are the angles that have their terminal side on one of the axes of your coordinate plane. So if the value is on the x-axis on the positive side, we would have a value of r and 0. So this is if it's at 0 degrees or 0 radians. Your x value would be r, your y value would be 0. If it's on the positive y-axis, our ordered pair would be 0 and r, and this would be at 90 degrees or pi over 2. If we are at the negative x-axis, this would be at 180 degrees or pi radians, and our coordinates would be -r and 0. And if you are in the negative y-axis, or at 270 degrees or 3 pi over 2, your ordered pair would be 0 and -r. So you can find the values of a trigonometric function of quadrantal angles by choosing a point on the terminal side of the angle and evaluating the function at that point. To make our calculations easier, we're going to go ahead and let r equal 1. So we need to find the exact values of the function for the trigonometric functions. And if we can't find one, we're going to write this as undefined. So on the first one, we have sine of 180. So 180 would put us over here. That's the ordered pair of -r and 0. Remember, sine is y over r. We know our y value is 0, and we said to make our life easier, we're going to let r equal 1 in this case. So the sine of negative 180 degrees would equal 0. 3 pi over 2 is down here, and that is going to have the ordered pair of 0 and negative r. Tangent is y over x, which is negative r over 0, but you can't divide by 0, so this would be undefined. 4 pi is doing one circle gives us 2 pi, so 2 full circles would give us 4 pi. This has an ordered pair of r and 0. Secant is the reciprocal of cosine, so we know it's r over x. X in this case is r, and r over r will simplify to be 1. Or we know that we said the r value is 1, so it would be 1 over 1, which would simplify to just be 1. For cases that the angle are not acute and not on the quadrantal, we can use the reference angle to find our trigonometric identity. So our reference angle is an acute angle formed by the terminal side and the x-axis. So you're just going to find whatever distance it is from your terminal side of your angle to the closest x-axis. You're always going to find an angle that is less than 90 degrees. So sketch the angle, then find its reference angle. So if we sketch the angle of 210 degrees, remember we're measuring this counterclockwise. So this is 210 degrees. Your reference angle is going to be from your terminal side back to your closest x-axis. Now we know that this is 180 degrees, so 210 is 30 degrees past that. So our reference angle in this case would be 30 degrees. We need to sketch 5 pi over 3. So a whole circle is 2 pi. So this is 0 and 2 pi. Another way to write 2 pi is to write it as 6 pi over 3. So 5 pi over 3 is going to be around the circle, almost to the end of the circle, but not quite there yet. So this is 5 pi over 3. To find the reference angle, you just need to see what the difference is back to a full circle. So if a full circle is 6 pi over 3, and we've already done 5 pi over 3, that leaves us as pi over 3 as our reference angle. Now, if you need to evaluate the trigonometric function of any angle, the first step is determine the reference angle. Then you're going to find the values of the trigonometric function for that reference angle. And then you're going to use the quadrant in which the terminal side lies to determine the sign of the trigonometric function. So, if we are taking a look, in the first quadrant, your x value is positive and your y value is positive. So sine, cosine, and tangent will all be positive. In quadrant 2, x is negative and y is positive. Now remember, sine is y over r. So since y is positive and r is always positive, your sine would be positive in that quadrant. Cosine is x over r. Since the x is negative, cosine will be negative. And tangent is y over x. Since y is positive and x is negative, that would make us have a negative answer. In the third quadrant, x is negative and y is negative, so sine and cosine will both be negative. But since tangent is y over x, those two negatives will cancel out, and you'll be left with a positive answer. And in quadrant 4, x is positive, but y is negative. So remember, sine is y over r. Since y is negative, sine would be negative. Cosine is x over r. Since x is positive, cosine is positive. And tangent, again, is y over x. Since one is positive and one is negative, your answer will be negative. Now, these are the exact trigonometric values for three angles that are used very frequently. We have 30 degrees, or pi over 6, 45 degrees, or pi over 4, and 60 degrees, which is pi over 3. So we need to find the exact values for each of the trigonometric, or each of these expressions. So 120 degrees would be about here. So we need to find the reference angle. The reference angle takes you to the closest x-axis. So our reference angle, remember this is 180 degrees here. So to get from 120 to 180, we need to go 60 degrees more. So we're going to find the cosine of 60 degrees. Now if we go back and look at that table, the cosine of 60 degrees is 1/2. But our angle ends in the second quadrant. Since it's in the second quadrant, we know that cosine will be negative. So the cosine of 60 is 1/2, but the cosine of 120 degrees will be negative 1/2. If we start with 7 pi over 6, that's going to be right here. Now we know half of a circle is pi, or we can write that as 6 pi over 6. So if we've gone 7 pi over 6, then to get back to that, we just need to go pi over 6 to get back. So our reference angle is pi over 6. If we need to find the tangent of pi over 6, tangent of pi over 6 is radical 3 over 3. And our terminal angle is in the third quadrant. So tangent in the third quadrant is positive. So the tangent of 7 pi over 6 will be positive radical 3 over 3. Now, we're going to look at the reciprocal functions, so cotangent and cosecant. You're still going to start the same way. So 135 degrees would be right here. To get to our closest x-axis, to get to 180 degrees, we're going to see the difference is 45 degrees. So if we go back and look, we're looking for cotangent. Remember, cotangent is the reciprocal of tangent. So if we look at tangent for 45 degrees, we have 1 or 1 over 1. And so if tangent of 45 degrees is 1 over 1, then cotangent of 45 degrees is just the reciprocal of that, which in this case is still 1 over 1. Since the terminal side is in quadrant 2, whatever the sign is for tangent would be the same for cotangent. So since tangent in the second quadrant is negative, cotangent in the second quadrant would also be negative. So cotangent of 135 will be a negative 1. If we look at cosecant of 15 pi over 4, a full circle, we said, is 2 pi. If we write that in terms of a denominator of 4, we would multiply the numerator and denominator by 4, and that would give us 8 pi over 4. So obviously 15 pi over 4 is more than one circle. If we subtract 8 pi over 4 from that to find a coterminal angle, that's going to leave us with 7 pi over 4, which would put our terminal angle right here. So our reference angle in this case will just be pi over 4. Now cosecant is the reciprocal of sine, so if we find the sine of pi over 4, the sine of pi over 4 is radical 2 over 2. But we are in quadrant 4, and sine in quadrant 4 is negative. So the sine of 7 pi over 4 would be a negative radical 2 over 2. To find cosecant, we just need to find the reciprocal of that. So cosecant of 7 pi over 4 would be a negative 2 over radical 2. We can't leave that radical in the denominator, so we're going to multiply the top and the bottom by radical 2. This would give us negative 2 radical 2 over 2. That 2 on the top and the 2 on the bottom can cancel. So we're going to be left with the cosecant of 7 pi over 4 is equal to negative radical 2. Or that the cosecant of 15 pi over 4 is negative radical 2. We're going to let tangent equal 5 over 12, and we know that the sine is less than 0, so we know that the sine is negative. Now, we need to remember that tangent is y over x, and we know that sine has to deal with y over r. Now, r always has to be positive, so for sine to be negative, that means we know the y has to be negative. And for this fraction to be positive, if y is negative, it means x is also negative. So we know that x is going to equal negative 12. We know y is going to equal negative 5. We need to find the value of r. Remember, r is equal to the square root of x squared plus y squared, or negative 12 squared plus negative 5 squared. 144 plus 25 is going to give us radical 169, or r is equal to 13. So if we find our 6 trig functions, remember sine of theta is y over r, or negative 5 over 13. Cosine of theta is x over r, or negative 12 over 13. And we already know that the tangent of theta is y over x, but we already knew that that was 5 over 12. Cosecant of theta, remember, is the reciprocal of sine, so this will just be 13 over negative 5. Secant of theta is the reciprocal of cosine, or r over x, which is going to be 13 over negative 12. And cotangent is the reciprocal of tangent, or x over y, which is 12 over 5.